All right, can you see my screen?
Yes, sir.
Yes, sir.
Fine, let's start our journey. So today I'm going to talk about vector and scalar. I know all of you are familiar with this topic because you're learning this thing from your studying or school life, but this is important, very important. It will be important at the end of your life. Remember, that's why we are still talking about, we talk about the vector at the very beginning of your university life or very beginning of this course, because in the field of engineering, it's definitely you're gonna never neglect the vector and scalar. So I'm saying that, so suppose if I ask you why you are at the BRAC University or why you are at the CSE department, what would be your answer? Hmm? If I asked you why you are at the CSE department, the BRAC University, what would be your answer? Tell me, come on, guys, speak up. Hello, am I
So
audible to you?
should I start?
Yeah, definitely. Anyone.
Thank you, sir. Actually, sir, BRAC is one of the renowned universities of Bangladesh, and other than that, the knowledge and expertise which the teachers of BRAC University has and which they can give us will be very much efficient for us, which can make us efficient and can not only just teach us but also can give us the knowledge which we require to do well in the later life. Like
Exactly.
you
That.
said,
Yeah.
we have to get some skills, we have to develop our skills. Other than that, we will not succeed in the later part.
Exactly. So that's when you have some target, right?
Yes,
After
sir.
the 4 years, you're going to be skillful engineer, right? So that's your target. So that's when that is also the vector, right? So that's when you have some direction. You are moving towards in that direction. After 4 years, you are going to be skillful engineer. That's your target. That's his vector. And nothing else does that. So that's why vector will be very important in every single step of your life. Do not neglect this thing. All right, we define in it that way. So vector has a basically the quantity which has a magnitude and the direction, right? And the scalar has only that magnitude. It has no direction. So for example, if I say a car is traveling towards some speed, say if I say the car is moving at a 5 meter per second, then what would be that? If I say the car is moving at a 5 meter per second, will it be vector or it will be scalar?
Scalar.
It is
It's
scalar.
scalar because
It will
there's
be
no
scalar.
direction.
Yeah, it has no direction, right? But if I say it's moving 5 meter per second towards the north,
Then
then
it's a
it would be
vector.
vector,
Vector.
right? In that case, it would be velocity because velocity is a vector. But if I say the car is moving at 5 meter per second, it would be speed because speed is a scalar quantity, but the velocity is a vector. So that's a 5 meter per second towards the north, it would be a vector. So that's how actually we differentiate between the vector and scalar. All right. To talk about, we express generally that vector in graphical representation. Basically, we use some vector in way. If I express a vector A, and we express a overhead arrow above the letter. That's the general procedure. Actually, we will also follow that one. But before that, I'm going to talk about some different type of vector. Actually, we should know this thing. When we define, say that positive and negative vector. One more thing, my handwriting is very bad. I do sometimes I do it intentionally in my in-person class because you guys never ask any question in the classes. Actually, you feel hesitate. Sometimes I write in that way so that when they are going to make a copy of my lecture from the board, so at least they will ask what you have write in that code or that what. So I'll get one question from that actually. So that's why I write in that way. So, but this thing is not actually that working in this live session. All right. So positive and the negative vector is basically, say a vector is towards that direction. If you choose this is a positive direction, or you are familiar with this Cartesian coordinate system, so this is your positive x-axis, this is your positive y-axis, and this is your positive z-axis. Then any vector towards that direction, I will say this is a positive vector. Any vector towards that opposite direction, which is negative x direction, I will say this will be the negative vector. So that's why if I say this vector A is positive toward that direction, I will say this vector which is towards in the negative direction. And remember this, although my drawing is not exact, but this will be basically the angle between these two vectors must be also that 0. I'll come to that point. So this is called actually the positive and the negative vector. Or if you choose this is your positive vector, then A would be negative vector because it is in the opposite direction. That actually depends on the convention, which direction you choose the positive and which direction you choose the negative. All right, the second one I should discuss, say that parallel and anti-parallel vector, which is nothing. You can say there is a positive and negative vector. Say if the two vector is in the same direction, they could be either they could be equal magnitude or different magnitude. Like this is a different magnitude, but the angle between them must be equal to the 0 degree. Then we'll say this is actually that parallel vector. And anti-parallel, say one vector is toward that direction, which is say that the vector A, and another vector is towards in the opposite direction, then they are anti-parallel, and in that case the angle between these two vectors actually that 180 degree. This is important point for that parallel and anti-parallel vector. Then another vector we define, say, is called the null or that 0 vector, which has a 0 length. You can say it has a 0 length. How we're going to find out? Say, if you have a vector A and another vector is the B, the same magnitude, but in the opposite direction. Or you can write in another way, mathematical notation. Say you have a vector A, which you express that the 5i, where I is the unit vector, right? I'll come to that point, what is the unit vector, but I think you're familiar with this I hat. So, and in that case, say that the B would be minus 5i hat, which is in the opposite direction. Now, if you add these two vectors, A plus B, that's going to be the 0, because plus 5 and the minus 5 going to give you the 0. That would be basically that null vector or the 0 vector, which has a length is 0. Say I have a vector, it's a vector can be represented in the two ways. One is basically the graphical representation, another is the mathematical representation. This is actually the drawing I'm doing that graphically, and this is actually that mathematical representation. I'm going to talk about basically that graphical representation today. We'll also talk about the mathematical representation in the later part on next day. So this is a vector A. Say if I want to draw the twice A of that vector, what I should do. So since I multiply that vector A by a scalar quantity 2, I will basically then double that unit, right? So since I take, this is the smallest unit over here, I make that double. So this will be actually the twice A, which is actually the multiplication of that vector. So we can multiply by a scalar quantity of that vector. We can also multiply by a negative scalar quantity. So this, if I write them the minus twice A, what it will give me? In that case, the direction of this vector will be in the opposite direction. Right? I just flip the direction of that vector. That's not actually say that the multiplication of that vector. That's how we can do that. What about, say, addition of that vector? Say, to addition of that one, say, I'm going to talk about a case like that. Say, I have a table as a tabletop. There is a point onto that table, which is the point O. It's a top view or perspective view of that table. And there is a point, is the P, is that point P. And you want to go from point O to point P. So this is the case. Say your start over there. You want to go from point O to P. When you start from O to P, at the same time, that table start to move towards that direction. Table can move actually towards the right order. It is happens simultaneously. After reaching the point P, you will find out that you reach another point. Say that point, this is actually that S. It means that the P point will be shifted to the S, right? So say if I draw that new position of the table from, say that this dotted line is representing that new position of that table. Although my drawing is not exact, but think about it in that way, right? In that case, that P will be shifted to that S, right? Or if you want to draw the precisely, say, since I draw in a bigger way so that you can understand. So since I shift the 2 units, so I should also say that this is actually that S. Do you understand this thing? Can you visualize this thing? This is very important, very important. So once you start from that point O towards the P, but at the same time, if the table moves towards that rightward direction, after reaching the point P, you will find out that you reach that point S. If this happens simultaneously, then I can say you basically travel from O to S, right? In that case, I can write that displacement OP plus PS must be equal to OS. Am I right? This is a very fundamental law. This is a very fundamental law, which is known as the vector triangle law. Vector triangle law. So that's mean vector triangle law. If you have a vector, that vector A, another vector is the vector B, they are connected in a way, I will come to that point, then this would be my resultant vector C. That means I can write that A plus B must be equal to the vector C. This is known as actually that vector triangle law. And there is some condition to apply this law. First condition is condition number 1. Two vector must be connected to head to tail connection. Look at this. This call actually that head to tail connection. It means that head of the first vector, which is the vector A, is connected to the tail of the second vector of the B. This is the first condition. If you want to use the vector triangle law, this condition must be satisfied. Otherwise, you cannot use that one. The first condition, the vector should be arranged in such a way that head of the first vector must be connected to the tail of the second vector. And second one is, if vector is rotated in the clockwise direction or counterclockwise direction, then the resultant vector will move to the opposite direction. So say for this case, if I move from A to B, basically I am moving in that counterclockwise direction, right? Say I'm moving from that point to this direction, so I'm moving in the counterclockwise direction. Then the resultant vector would be in the clockwise direction, or you can say another way, the direction of the resultant vector would be tail of the first vector towards the head of the second vector. Or say I have a vector like that. This is a vector A. This is a vector V. Still they are head to tail connection. They are right now moving to the clockwise direction. Then the resultant vector will be towards that direction, which is actually the counterclockwise direction. These are the two conditions to use this vector triangle law, and this is a very, very important law. This is the only thing I'm requesting you to carry in your head. Somehow you have to carry this information in your head. I don't care about whether you memorize or blah 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 everything, but somehow I requested not more than 4 or 5 things to remember for this course. Among them, this is one thing, because I will use this thing randomly after your mechanics part, end of this case, end of this mechanics part. I have to use this thing. It's a very useful formula, vector triangle law. Only thing I introduced for this course for today. After this, this is very
Can you
important.
please repeat the second condition?
Yes, second condition is actually if you move the vector are moving from say that clockwise direction, then the resultant vector would be counterclockwise direction. So if I say my vector is vector A and this is the vector B, say if I move from A to B, I'll basically move into the counterclockwise direction, right? In that way. In that case, the resultant vector would be basically that clockwise direction. You're familiar with the clockwise and the counterclockwise direction, right? So if you move in that way, which is counterclockwise, this is actually that clockwise direction. That's the case. Can I give 2 minutes extra? Can I take 2 minutes extra?
Yes,
Sure, sir. Sure.
Yes, sir.
Yes, sir. Yes, sir.
Yeah, thank you very much. Thank you very much. Say, what if, say, I have to vector in such a way, this is the vector A, and this is the vector B. I want to add them together. And remember, this is actually that origin also. This vector triangle law is also the origin of addition of two vector. Actually, we are adding in that way. That's how actually we add this thing. Now over here. So if I want to add A plus B, how am I going to add that one? Basically, they are not satisfying the first condition, head to tail connection, right? Then I cannot use this one. So what I can do actually, I can shift that origin of that vector without changing the magnitude and the direction. I can do it. Remember, you have that also, that power, without changing the magnitude and the direction of vector, any vector, anywhere you want, you can do that. Because in that case, basically you are shifting the origin. You are not changing the vector magnitude and not changing that vector direction. So that means that you are not changing the vector B. You just shifting that origin of that vector. Right? So in that case, the vector is not going to change. So if the case, then I will rearrange that one. I'll place it over there. Then I can say my resultant vector would be from A to tail connection. So I will draw, this will be my resultant vector. And that's how I can write, this will be my A plus B, right? Because this vector A and B are head to tail connection, which is basically the counterclockwise direction, and the resultant vector in the clockwise direction. It satisfies this vector triangle law condition. And that's how actually we can use this vector triangle law. What about, say, if I want to find out the A minus B, what I have to do? Do you think that I have to, because A minus B basically I'm subtracting, right? So do you think that I have to introduce another theory or another law to subtract to vector? What do you
So
think?
we can change the direction of B.
Exactly, right. So when you basically, you're familiar with this thing. When you write, say you give the instruction your machine write 5 plus 2, it automatically give you the 12. When you write give the input 5 minus 7, it automatically give you the 2. Do you think that your machine used to different program to perform this operation, to different operation?
Maybe not, sir. Actually,
Yeah,
maybe the machine uh, do the same thing in the both places. In the second place, he do 5 plus minus 7.
exactly. Exactly, he did. He used the same program, but instead of that, they flip the number actually. He basically they're doing the addition in the both case. If it has to the different program, then your computer operating system would be the more than 20 GB. For every operation, it has to write a program. Right? The same thing over here, say this is the idea actually. So if you want to write, say this is my vector A, and this was my vector B, right? What I'm going to do, I will just flip the direction of the vector B. It will be that minus B. How I can do that? I will just multiply this one by minus 1. Then it will flip its direction. If it's flip its direction, then look at this. Now this time, head of the first vector is connected to the tail of the second vector. They are now right now in the clockwise direction. Then I can say this is will be my resultant direction, and it would be, I'll write A plus minus B, which will automatically give you the subtraction of that two vector. And that's how actually we can subtract or add two vector in that way. This is actually the graphical representation I'm talking about, and this graphical representation is very important. Although we will focus on the mathematical representation most of the time, but the graphical representation will help you to, without doing the calculation, you can make a prediction. So if you release a particle, or if you which direction it is moving, if you have more than 2 or 3, graphically visualize that the trajectory of that particle, then without doing the calculation, you can at least predict that what would be the resultant direction of this vector. It will give you that idea actually, the graphical representation of that vector. So that's why it is important. So all right, thank you very much. Thank you very much. I took more than 2 minutes actually. Thank you all of you. This is the end of this today's live session, and I will upload this live session into my Slack channel. If you guys join over there, you will find out that thing over there. All right, thank you very much. See you in the next Tuesday.
Thank you, sir.
Okay, sir.
Thank you,
Thank
sir.
you, sir. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Assalam.
Assalamu alaikum, sir. Allah Hafiz.